Alright, so I think I'm recording here. Let's continue taking a look at the properties of these exponential functions. Here we have three transformations on the basic function e to the x. Now remember, the e is just a number like pi. It's an irrational number, 2.718. So if we're thinking about what the graph of e to the x looks like, the base is bigger than 1, and it looks a very rough sketch like this. Alright, it has a y-intercept of 0, 1. What that negative sign is going to do, that's in front of the x, is reflect this graph across the y-axis. And then what this 3 is doing is vertically stretching this graph away from the x-axis. And then the minus 2, that's going to push this graph that currently has a y-intercept of the x-axis. It's going to push this graph down 2 units. So my basic graph that I'm looking for has been stretched but then pushed down 2 units, and it's, oops, I just drew it decreasing. I didn't draw the others decreasing, did I? I did. Oh, because it is decreasing. The negative, it had a reflection. I'm not even paying attention. So it looks like this. Alright. So the range has a minimum, it's from -2. The range of this is from -2 up to positive infinity. It's lagging again. So what choice is that? That's choice C. Alright. The end behavior. Well, maybe I shouldn't have erased all that. The end behavior. As x is approaching negative infinity, as you move to the left, the graph is going up without bound. So it's going up towards positive infinity. As you move to the right, as x gets bigger, the y values are getting closer and closer to -2. Alright, so the top one here, let's see, as y is approaching -2, this e is the description we want for the end behavior. Alright. To find a y-intercept of any function, we let x equal 0. If we're trying to find the y-coordinate of this point, we know that if you're on the y-axis, you have it moved left or right, and so the x-coordinate is 0. So if we input 0 into this function, the opposite of 0 is just 0, and e raised to the 0 power by definition is 1, and 3 times 1 is 3, and 3 minus 2 is 1. So my graph should have been, I guess, like that. That vertical stretch before we pushed it down was enough that even pushing it down, that it was still above the x-axis. Sorry about that. So the end behavior 0, 1 is there in choice C. Hope that helps, and I'll talk to you later.